I welcome all of you for the discussion on applications of PDE. So in this video we are going to discuss about the solution of Laplace equation by the method of separation of variables. ಎಲ್ಲರಿಗೂ ಸ್ವಾಗತ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ PDE ಅಡಿಯಲ್ಲಿ ಲ್ಯಾಪ್ಲಾಸ್ ಈಕ್ವೇಷನ್ ಸೊಲ್ಯೂಷನ್ ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈ ಮುಂಚಿನ ವಿಡಿಯೋಗಳಲ್ಲಿ ಈಟ್ ಈಕ್ವೇಷನ್ ಮತ್ತೆ ವೇವ್ ಈಕ್ವೇಷನ್ ಸೊಲ್ಯೂಷನ್ಗಳನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಮೊದಲನೇ ವಿಡಿಯೋದಲ್ಲಿ ಹೇಳಿರೋ ಹಾಗೆ ಈಟ್ ಈಕ್ವೇಷನ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ PDE ಅಂತ ಬಂದಾಗ ಮೂರು ಮೇಜರ್ ಈಕ್ವೇಷನ್ಸ್ ಅನ್ನ ನಾವು ಯಾವಾಗಲೂ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ದಟ್ ಈಸ್ ವೇವ್ ಈಕ್ವೇಷನ್, ಈಟ್ ಈಕ್ವೇಷನ್ ಅಂಡ್ ಲ್ಯಾಪ್ಲಾಸ್ ಈಕ್ವೇಷನ್. So Laplace equation, it is actually a second order linear differential equation which is widely useful in physics. Especially it is occurring in the solution of the problems related to electrical, magnetic and gravitational potentials, steady state temperatures and hydrodynamics. In all these problems we always find the involvement of Laplace equation. So this equation was discovered or coined by, discovered by French mathematician and astronomer Pierre Simon Laplace. So in the honor of his contribution, the equation itself called as Laplace equation. So now let us move to the solution of Laplace equation. Solution here, instead of given, I will consider. Can either move with given or consider. That is not a major difference. So consider the Laplace equation. Dou square u by dou x square plus dou square u by dou y square equal to 0. Since we are applying separation of variables method, we have to assume dependent variable to be the product of independent variables. So put u equal to capital XT. Oh, here we have y, right? We have to take y, where capital X equal to function of small x and capital Y is function of small y. Then this equation will become dou square of xy by dou x square plus dou square of xy by dou y square equal to 0. Right? Now I have to differentiate this. See, this will be y into dou square y by dou x square actually, but capital X is a function of single variable small x, so we can write d. So d square x by dx square plus x into d square y by dy square equal to 0. So divide both sides by xy. Divide both sides by xy. So then it becomes, here y get cancelled. 1 by x into d square x by dx square plus 1 by y into d square y by dy square equal to 0. Or you can write this as 1 by x into d square x by dx square equal to minus 1 by y into d square y by dy square. You can call the common value as k. Right? Now considering this pairwise, we get 1 by x into d square x by dx square equal to k, and here minus 1 by y into, you can take this negative sign to the right hand side, so right, 1 by y into d square y by dy square equal to minus k. Okay, now it will be d square x by dx square equal to k into x, and here d square y by dy square equal to minus k into y. So you can rewrite this as d square x by dx square minus kx equal to 0, right? Similarly here d square y by dy square plus ky equal to 0, right? Now assume here for the first equation, assume capital D stands for d by dx. Assume capital D stands for d by dx. In light of this, this equation can be written as d square x minus kx equal to 0, or d square minus k into x equal to 0. D square minus k into x equal to 0. Similarly, here assuming capital D stands for small d by dy, it will be d square plus k into y, okay, d square y plus k into y equal to 0. So that will be actually d square plus k into y equal to 0. Now we have to consider various cases. So case 1. Case 1. So now under case 1 we will consider k to be 0. So assume k 0. Put k equal to 0. So assume, that is best. Assume k 0. If you assume k 0 in this equation, we get d square into x equal to 0. From that, if you write auxiliary equation, m square equal to 0. So m is 0 comma 0. If you write the solution, x will be c1 e power 0 into x plus repetition into c2 e power 0 into x. So we get capital X equal to c1 plus x c2. If you come to this, here we get d square into y equal to 0. So from that, m square equal to 0, that is the auxiliary equation. So m equal to 0 comma 0. So capital Y equal to c1 e power 0 into y plus repetition of the root into c2 e power 0 into y. So you get capital Y to be, okay, see, we have already used c1 and c2, right? So let us write c3 and c4. It is c3 plus c4y. Hence the required solution is, hence the required solution is u equal to c1 plus x c2 into c3 plus y c4. So this is the required solution when k is 0. Next, I have to consider when k is positive. Case 2. Assume k greater than 0. In that case, you can assume k equal to p square for some p. Definitely p square must be greater than 0, right? Because k is greater than 0. Then this equation will become d square minus k into x equal to 0. That will become d square minus p square into x equal to 0, and here parallelly we will be having d square plus p square into y equal to 0, right? So let us compare this. So d square minus k we have, so d square minus p square, d square plus k, d square plus p square, right? Now, okay, if I write the auxiliary equation, m square minus p square equal to 0, so m equal to plus or minus p. Here m square plus p square equal to 0, that implies m equal to plus or minus ip. So if I write the solution, capital X equal to c1 e power px plus c2 e power minus px here, and here capital Y equal to real part is 0, so c3 cos py plus c4 sin py, c3 cos py plus c4 sin py. So the required solution is u equal to c1 e power px plus c2 e power minus px into c3 cos py plus c4 sin py. Next, case 3. Case 3, you have to assume k negative. Case 3, assume k is negative. That is, we can assume k equal to minus p square for some p. Right? So then equation becomes d square plus p square into x equal to 0 here, and here d square minus p square into y equal to 0. This is almost converse of case 2. So we get m square plus p square equal to 0 auxiliary equation. From that m equal to plus or minus ip, and here m square minus p square equal to 0. From that m equal to plus or minus p. So here capital X equal to c1 cos px plus c2 sin px, capital Y equal to c3 e power py plus c4 e power minus py. Hence u equal to c1 cos px plus c2 sin px into c3 e power py plus c4 e power minus py. So this is the required solution. So thus in each case we got different solutions, right? So we have determined solution of Laplace equation with respect to each condition. So when k is greater than 0, when k is less than 0, and when k is 0. So this actually gives all possible solutions of Laplace equation. So with this, our discussion of applications of PDE is come to an end. So I hope this we have I have conveyed in a better way. With that intention in mind, let us wind up the video. Thank you all.